All right, so we've been working with unit circles, triangles, talked about what happens for any given angle, and we try to keep it in terms of the unit circle or triangles. We're going to abstract it even more and now and talk about what does this graph look like, and think about what is this, what are these things, cosine, sine, and tangent, in terms of functions of theta. So the idea is, if I were to pick out an angle, we'll call it theta, that's going to define a point on this circle. Okay, this is a circle of radius r. If I were to change this angle theta, my value of x would change and my value of y will also change. So the question is, how do we think about this now as a function of theta? As I change theta, what's going to happen? Well, let's see. Let's back up a second and recall. Let me start over here. I think of this as in terms of the angle. I go back to my unit circle. So here my cosine is positive, my sine is positive, so in the first quadrant, if I pick a point there, the x value is positive, the y value is positive. If I pick a point here in the second quadrant, the cosine is negative, the sine is positive, because I'm above the y-axis and to the left, above the x-axis and to the left of the y-axis. If I pick a point there, both the x and the y are negative. So my cosine is negative, my sine is negative. If I pick a point in the fourth quadrant, let's see, so cosine now is over here is positive, sine is below, so that's negative. Okay, now notice also, if I pick this point here and I increase theta, I increase theta so that point starts to drift that way, it's going to be moving up and to the left. So that means that since it's moving to the left, the cosine is decreasing. Since it's moving up, the sine is increasing. In the second quadrant, okay, if I increase theta, I'm going to be moving along this way. Cosine is still moving to the left, so it's negative and decreasing. Okay, so that's decreasing. Now it's moving downwards, so the sine is decreasing. In the third quadrant, let's see. So now we're moving along this way as my angle changes. I'm moving now to the right, so the cosine is negative, but it's increasing. And I'm also in a negative y position and decreasing, or moving downward. So I get that. In the fourth quadrant, so I'm moving along like this. So as I go this way, my cosine is positive and still moving to the right. So it's increasing. And let's see, my y value is negative, but it's moving upwards, so it's increasing. Okay. So what does that mean? If I were to graph these things, right, so in terms of theta, what's going to happen? Well, let's see. So this angle right here, this is going to be at x equals 1, y equals 0. That's angle's 0. As I come up to here, that angle is pi over 2. That angle is pi over 2. If I come down to there, that's going to be pi. If I come across to here, that's 3 pi over 2. Look at that. And now as I come across here, now it's at 2 pi. Like so. But I can keep going. I can keep going around like that again. So if I go around another pi over 2, so that's going to be what, 5 pi over 2. And if I come around to here, that's going to be 3 pi. And then I'm going to come across to 7 pi over 2, then 4 pi, and just keep going around. Notice I could also, if I started here, I could also go back around the other way. So if I came around this way, that's negative pi over 2, negative pi over 2, to keep going around, negative pi, negative pi. So let's see, so this is going to be negative 3 pi over 2, negative 3 pi over 2, negative 2 pi, and negative 2 pi. Okay? So So let's see, so what is sine going to do? So sine, when the angle is 0, my y value is 0. When I come across to pi over 2, it's going to go up to 1. As I come down to here, it's going to go down to 0. And to here, it's going to go to negative 1. As it comes across to here, it's going to be 0. And then it's going to just start repeating itself, like so. Okay. Now it's going to be tempted to just make straight lines there, because it looks like that. But notice, from here, it's going to start increasing very fast, slow down, and then slowly start to decrease. So if I do that, it's going to come up very fast, turn around slowly. That's pretty bad, but you end up getting something like that. And it's going to keep doing this on forever. Okay. If I'd gone around the other way, right, it's going to start at 0, it's going to get negative, go down to -1, and then slowly turn around and come back. So I would have found something like that. Okay. What's happening with cosine? It's the x value, so when the angle is 0, the x value is 1, like so. So I come across here to pi over 2, the x value is 0. When I come around here, the x value is going to be -1. So I come to here, the x value is 0. And then as I get to there, my x value back at the starting point, and it's going to be 1. And it's going to start basically repeating itself like that. Again, it's going to look like, kind of looks like that. But notice, here it's going to slowly start to change. And then up here it's changing pretty fast. And then it's going to be slowly changing. If I graph it, I'm going to get something like that. And likewise, if I go around backwards, it's going to start decreasing. Oops, and that's pretty much wrong. That's what I get for being sloppy. It's going to go to 0, -1, 0, and +1. Okay? So I can think of this x and the y coordinate, right? So for any point here, I've got an x and y coordinate. There's an angle associated with that, and since r is a constant, the value of, say, x over r cosine is only going to depend on the angle, and as my angle changes, as I go through the different quadrants, I'm going to go through this pattern. Same thing is going to happen with sine, and I'm going to have something like that. Okay? All right. Now, I'm going to go through and look at each of these two things separately and think about what kind of transformations I can do to change the way this looks. And I'm going to focus for now on vertical changes. And in a separate video, we're going to look at what happens for horizontal changes. Okay, so let's look at the sine function first. Let's do all this. So in terms of vertical changes, what can I do to a sine function? The idea here is I can change it like that. Okay, so I can basically scale it vertically and then shift it vertically, depending on whether or not d is positive or negative. For now, we're just going to assume that this is a positive scale. We can change that later. First thing to notice, though, is if I look at this thing here, what do I have? If I just look at what happens from 0 to 2 pi and ignore the rest of it, I go through one complete cycle. Right? It goes from up, down, down, and up. And then after that, it just keeps doing the same thing over and over and over. So if I can figure out what's going on in here, I can basically figure out what's going to happen everywhere else. Okay, so what do I have? So I've got some length. Right, this distance here is going to be 2 pi minus 0. It's going to go +1 above the middle, to -1 of the middle, okay? And so I'm going to refer to this thing, this distance, I'm going to call the amplitude. So from there to there is the amplitude, but notice from there to there is also the amplitude. So the amplitude here is not 2, even though it goes up and down a total of 2, the amplitude is how far it goes away from the middle, so the amplitude here is only 1. Okay? And notice this thing is not shifted up or down or anywhere, it's centered right at 0. Okay? So if I take a look at this, this is going to scale this thing vertically, it's either going to make it go up like that if A is bigger than 1, if A is between 0 and 1, it's going to shrink it down. And then this plus D is going to take the whole thing and shift it up if it's positive, or shift it down if it's negative. Okay? So if I have something like this, let's keep this in terms of theta for now. Okay, then, let me be careful here, let me line this up a little more carefully. Let's say I'm going to have my pi over 2, pi, 3 pi over 2, 2 pi, 3 pi, minus pi, minus 2 pi, okay. Let's just, for kicks, pretend that this d is positive. If that's the case, then this is going to shift everything up, take this whole graph and shift it up some d. When sine is equal to 1, this is going to be a plus d. So the biggest this can ever get is a plus d. Sine also comes down to -1, so this could be negative. So this can come down as far as minus a plus d. So this new function I'm defining has to oscillate between here and here. Everything's going to be between here and here, and it's going to wobble around this y equals d line. Okay? So this is going to shift it, and this is going to stretch it. And again, we're going to call this distance here the amplitude. So by definition, this thing I'm calling the amplitude is just equal to a, right? Because this thing, sine goes between plus or minus 1. This is going to go between plus or minus a, as sine goes between plus or minus 1, and then I'm going to have to shift everything up by d. So what happens then is, so this is going to be, when sine is 0, I'm going to have 0 plus d. When sine is 1, I'm going to come up to here. It's going to be 0 to here to here. So it's going to look something like that. Okay, that's pretty bad, but you get the idea. Okay, what happens with cosine? So let's back up and ask what happens if we shift or scale the cosine function vertically. So we redo this. Okay. So this is going to be the cosine. Now the cosine goes between plus or minus 1, so it's going to go from 1 to minus 1. Draw that, so that's minus 1 there. Okay, it's going to start, and when theta is 0, it's going to start at 1. Going to do something like this. Like so. Okay. And again, notice as I go from 0 to 2 pi, so I have one full cycle. So the width of that box is 2 pi. The amplitude is 1. It's going to bounce around the y equals 0 line, but it's going to go up to 1 and down to -1. So we're going to define the amplitude to be exactly the same thing. It's how far away from the middle that you go. And so now if I have a function, y equals a cosine theta plus d, we're going to ask what this looks like. Okay? I'm going to assume d is negative in this next picture, but I'm going to assume that a is positive. So what's it going to do? Okay, so this is whatever this function is. So I have something like this. Now this should be a theta. When theta is 0, this cosine is going to be 1, so I'm going to have a plus d. So let's see, so this is going to be at a plus d. Okay, I'm going to assume a is positive. When it's 0, it's going to be down here at d. And when I get down to here, this cosine is going to be -1, so this is going to be minus a plus d. Okay? So this function is going to wobble around a plus d to minus a plus d. And the line that's going to wobble around is y equals d. Okay. So now what do we have? This thing at theta equals 0 is going to be 1, so it's going to start here. When I'm at pi, it's going to be at its lowest. 2 pi is going to be at its highest. Pi is it's going to bounce around like that. So this is going to be at its lowest, highest, lowest. So I'm going to have something like that. Okay. All right. Let me do one last example, and I'm going to give you an example where you figure out what the A and D is from a description. Okay, so what do we have? We've got a cosine function. It's in the form of a cosine theta plus d, so it's exactly like what I had here. And I assume that its max is 4 and its minimum is -3. So the question is what is a and d? Okay. So what does that mean? So if I were to graph this thing, so this is going to go from 4 to -3. Yep, it's going to look like that. It's a bit exaggerated. So I have that. So what do I know? I know that at the top of this thing, a plus d, so when this is, when cosine is 1, I'm going to be at a plus d, that has to be 4. Now down here at the bottom, this is when cosine is -1. This is going to be minus a plus d, and I know that that's going to be -3. So the question is, if I know this and I know this, how do I figure out what a and d is? So I've got two equations, two unknowns. I can just work with those equations. So what do I have? So my first equation means A plus D equals 4. So that means A is 4 minus D. So I'm just going to solve for one, plug it into the other, and then see what happens. So my next equation is minus A plus D is minus 3. I know that A is 4 minus D. I've got to be very careful about the signs. If I distribute the minus sign, I get minus 4 plus D is minus 3. I'm going to add 4 to both sides. I do this in 2 steps. This is minus 3 plus 4 is 1. D plus D is 2 Ds. So my D is 1/2. Now if D is 1/2, my A is going to be 4 minus D. So that's going to be, what, 3.5? Okay, so there's my amplitude, and there's my D.